We're supposed to go. Where is the console room? What is that? Oh, message coming through. The console room. That way. Here we are. Wonderful. There we are. There's the. Okay, now. Ooh.
Hello, mister. This is the building TARDIS guide. If my calculations are correct, you have just landed on Europa on this first part of your adventure. Please be careful and take care. And please do not exit the ship under any circumstances, as there is zero oxygen out there. But if an emergency occurs, I will activate automatically. I will try and do my best to guide you on your journey. All you need to do is push the guide button on your handheld device, and I will do what I can.
Hi everyone, welcome to the special 4-part series, The Gas Giants, in which case we're going to be looking at 4 major planets in our solar system here in the Milky Way, and that is of course Jupiter, Saturn, Uranus, and of course Neptune, and this one being of course Jupiter. So we're starting off our adventures to find out more about this giant gas planet, the biggest in our solar system of course too. Now, as you can tell, we're in the TARDIS, which is the ship that the Doctor from Doctor Who rides around through space and time, and he's been more than generous to allow me to borrow it for just a little bit of time so we can go through the 4 planets a little bit quicker and find out what's going on as well too. And he has sent me a message to say that he wants the TARDIS back yesterday, so we have to make a bit of a quick run through all the 4 planets and of course return the TARDIS back to him as soon as we're done. But otherwise, if you're happy to join me on this very special 4-part adventure, and we're going to really enjoy and get some more information about each planet as well too. So without further ado, let us all start with Jupiter.
Jupiter is the 5th planet from the Sun and the largest in the solar system. It is a gas giant with a mass more than 2.5 times that of all the other planets in the solar system combined, and slightly less than 1/1000th the mass of the Sun. Jupiter is the third brightest natural object in the Earth's night sky after the Moon and Venus, and it has been observed since prehistoric times. It was named after Jupiter, the chief deity of ancient Roman religion. Jupiter is primarily composed of hydrogen, 90% by volume, followed by helium, which constitutes a quarter of its mass and a tenth of its volume. The ongoing contraction of Jupiter's interior generates more heat than the planet receives from the Sun. Because of its rapid rotation rate of 1 rotation per 10 hours, the planet's shape is an oblate spheroid. It has a slight but noticeable bulge around the equator. The outer atmosphere is divided into a series of latitudinal bands, with turbulence and storms along their interacting boundaries. The most obvious result of this is the Great Red Spot, a giant storm which has been observed since 1831 and possibly earlier. Jupiter is surrounded by a faint planetary ring system and has a powerful magnetosphere, the largest contiguous structure in the solar system after the heliosphere. Jupiter forms a system of 95 known moons and probably many more, including the 4 large moons discovered by Galileo Galilei in 1610, Io, Europa, Ganymede, and Callisto. Ganymede, the largest of the 4, is larger than the planet Mercury. Callisto is the second largest. Io and Europa are approximately the size of Earth's moon. Name and symbol. In both the ancient Greek and Roman civilizations, Jupiter was named after the chief god of the divine pantheon, Zeus to the Greeks and Jupiter to the Romans. Physical characteristics. Jupiter is a gas giant, being primarily composed of gas and liquid rather than solid matter. It is the largest planet in the solar system, with a diameter of 142,984 kilometers at its equator, giving it a volume 1,321 times that of the Earth. Composition. By mass, Jupiter's atmosphere is approximately 76% hydrogen and 24% helium, though, because helium atoms are more massive than hydrogen molecules, Jupiter's upper atmosphere is about 90% hydrogen and 10% helium by volume. The atmosphere also contains trace amounts of methane, water vapor, ammonia, and silicon-based compounds. There are also fractional amounts of carbon, ethane, hydrogen-sulfur, neon, oxygen, phosphine, and sulfur. The outermost layer of the atmosphere contains crystals of frozen ammonia. Through infrared and ultraviolet measurements, trace amounts of benzene and other hydrocarbons have also been found. The interior of Jupiter contains denser materials. By mass it is roughly 71% hydrogen, 24% helium, and 5% other elements. The atmospheric proportions of hydrogen and helium are close to the theoretical composition of the primordial solar nebula. Neon in the upper atmosphere only consists of 20 parts per million by mass, which is about a tenth as abundant as in the Sun. Helium is also reduced to about 80% of the Sun's helium composition. This depletion is a result of precipitation of these elements as helium-rich droplets, a process that happens deep in the interior of the planet. Based on spectroscopy, Saturn is thought to be similar in composition to Jupiter, but the other giant planets Uranus and Neptune have relatively less hydrogen and helium and relatively more of the next most common elements, including oxygen, carbon, nitrogen, and sulfur. Those planets are known as ice giants, because the majority of their volatile compounds are in solid form. Jupiter's mass is 318 times that of Earth, 2.5 times that of all the other planets in the solar system combined. Jupiter radiates more heat than it receives through solar radiation. Great Red Spot. A well-known feature of Jupiter is the Great Red Spot, an ongoing storm. It is known to have existed since at least 1831, and possibly since 1665. Images by the Hubble Space Telescope have shown 2 more red spots adjacent to the Great Red Spot. The storm is visible through Earth-based telescopes. The oval object rotates counterclockwise, with a period of about 6 days. The maximum altitude of this storm is about 8 kilometers, 5 miles, above the surrounding cloud tops. The spot's composition and the source of its red color remain uncertain. The Great Red Spot is larger than the Earth, and research suggests that the storm is stable and will be a permanent feature of the planet. However, it has significantly decreased in size since its discovery. Initial observations in the late 1800s. Juno missions show that there are several polar cyclone groups at Jupiter's poles. The northern group contains 9 cyclones, with a large one in the center and 8 others around it, while its southern counterpart also consists of a center vortex but is surrounded by 5 large storms and a single smaller one for a total of 7 storms. These polar structures are caused by Jupiter's atmosphere. Observation. Jupiter is usually the fourth brightest object in the sky, after the Sun, the Moon, and Venus, although at opposition Mars can appear brighter than Jupiter. Depending on Jupiter's position with respect to the Earth, it can vary. Exploration. Jupiter has been visited by automated spacecraft since 1973, when the space probe Pioneer 10 passed close enough to Jupiter to send back revelations about its properties and phenomena. Beginning in 1973, several spacecraft have performed planetary flyby maneuvers that brought them within observation range of Jupiter. The Pioneer missions obtained the first close-up images of Jupiter's atmosphere and several of its moons. They discovered that the radiation fields near the planet were much stronger than expected, but both spacecraft managed to survive in that environment. The trajectories of these spacecraft were used to refine the mass estimates of the Jovian system. Radio occultations by the planet resulted in better measurements of Jupiter's diameter and the amount of polar flattening. 6 years later, the Voyager missions vastly improved the understanding of the Galilean moons and discovered Jupiter's rings. They also confirmed that the Great Red Spot was anticyclonic. Comparison of images showed that the spot had changed hue since the Pioneer missions, turning from orange to dark brown. A torus of ionized atoms was discovered along Io's orbital path, which were found to come from erupting volcanoes on the Moon's surface. As the spacecraft passed behind the planet, it observed flashes of lightning in the atmosphere. The next mission to encounter Jupiter was the Ulysses solar probe. In February 1992, it performed a flyby maneuver to attain a polar orbit around the Sun. During this pass, the spacecraft studied Jupiter's magnetosphere, although it had no cameras to photograph the planet. The spacecraft passed by Jupiter 6 years later, this time at a much greater distance. In 2000, the Cassini probe flew by Jupiter on its way to Saturn and provided higher resolution images. The New Horizons probe flew by Jupiter in 2007 for a gravity assist en route to Pluto. The probe's cameras measured plasma output from volcanoes on Io and studied all 4 Galilean moons in detail. The first spacecraft to orbit Jupiter was the Galileo mission, which reached the planet on December 7, 1995. It remained in orbit for over 7 years, conducting multiple flybys of all the Galilean moons and Amalthea. The spacecraft also witnessed the impact of comet Shoemaker-Levy 9 when it collided with Jupiter in 1994. Some of the goals for the mission were thwarted due to a malfunction in Galileo's high-gain antenna. A 340 kg titanium atmospheric probe was released from the spacecraft in July 1995, entering Jupiter's atmosphere on December 7. It parachuted through 150 kilometers of the atmosphere at a speed of about 2,575 kilometers per hour and collected data for 57.6 minutes until the spacecraft was destroyed. The Galileo orbiter itself experienced a more rapid version of the same fate when it was deliberately steered into the planet on September 21, 2003. NASA destroyed the spacecraft in order to avoid any possibility of the spacecraft crashing into and possibly contaminating the moon Europa, which may harbor life. NASA's Juno mission arrived at Jupiter on July 4, 2016, with the goal of studying the planet in detail from a polar orbit. The spacecraft was originally intended to orbit Jupiter 37 times over a period of 20 months. During the mission, the spacecraft will be exposed to high levels of radiation from Jupiter's magnetosphere, which may cause future failure of certain instruments. On August 27, 2016, the spacecraft completed its first flyby of Jupiter and sent back the first ever images of Jupiter's North Pole. Juno completed 12 orbits before the end of its budgeted mission plan, ending July 2018. In June of that year, NASA extended the mission operations plan to July 2021, and in January of that year the mission was extended to September 2025 with 4 lunar flybys, 1 of Ganymede, 1 of Europa, and 2 of Io. When Juno reaches the end of the mission, it will perform a controlled deorbit and disintegrate into Jupiter's atmosphere. This will avoid the risk of collision with Jupiter's moons. Moons. Jupiter has 95 known natural satellites, and it is likely that this number would go up in the future. Of these, 79 are less than 10 kilometers in diameter. The 4 largest moons are Io, Europa, Ganymede, and Callisto, collectively known as the Galilean moons, and are visible from Earth with binoculars on a clear night. Galilean moons. The moons discovered by Galileo, Io, Europa, Ganymede, and Callisto, are among the largest in the solar system. The orbits of Io, Europa, and Ganymede form a pattern known as a Laplace resonance, For every 4 orbits that Io makes around Jupiter, Europa makes exactly 2 orbits and Ganymede makes exactly 1. This resonance causes the gravitational effects of the 3 large moons to distort their orbits as each moon receives an extra tug from its neighbors at the same point in every orbit it makes. The tidal force from Jupiter, on the other hand, works to circularize their orbits.
Sort of making my way through the TARDIS. It's bigger on the inside than the outside if you're not unaware of the ship. But I tell you what, there are just so many rooms and corridors and all sorts of things to discover here anyway too. But I'm not going to go too far because I don't want to get lost. And hopefully Morgan will help me out through the journey. I've only just had a crash course with the doctor in how to pilot this ship. So hopefully we get to where we need to be. And of course he gets his ship back very, very soon. But I hope you enjoyed that. I hope you enjoyed finding out more about Jupiter in greater detail and coming with me on this very special space journey, of course, and just can't wait to do the other 3 planets with everyone watching, and of course, yeah, just having a bit of fun and learning at the same time. But otherwise, thanks very much. Thank you for joining me, and I hope to see you for part 2, in which case we're doing Saturn, another big planet in our solar system. But you all take care. I'm just going to head back to the console room and hopefully steer our way through to Saturn. So until then, see you soon. Bye!